In this module, we're going to take a look at labor demand elasticity, or how the quantity of labor changes in response to changes in wages or the price of labor. So we'll look at the basic elasticity equation and setup. We'll consider a simple formula for elasticity. We'll also think about what is referred to as an own wage elasticity compared to a cross wage elasticity. We'll think about the presence of substitutes in the labor market versus complements in the labor market. And then we'll look at that second formula, the midpoint formula. It's one of two formulas we'll use, simple and midpoint. And then we'll look at the effects of total cost and elasticity, and we'll look at unions and contracts as they relate to elasticity. So first, let's take a look at the basic elasticity structure. Elasticity is a change in one variable in response to the change in another variable. So when we think about the labor market, one of the variables obviously we're looking at is the quantity of labor, or L, and the other variable that we look at is the price of labor, or wage. And when we think about this, we believe that in the labor markets, workers largely don't set their own wages, and firms largely don't set the wages. They're subject to the supply and demand relationship, so they're price takers, not price setters. So we think about then the change in quantity of labor, or the change in L, in respect to some given change in W, or the price of labor. Well, if we think about it, we have three different conditions. We can have something that's elastic, or something that's inelastic, or something that's what we'll refer to as unitary elastic. If something is elastic, then there's a large change in one variable in response to a smaller change in another. If this is a piece of an elastic band, if you'll think about it, when you give an elastic band a small change in pressure, physical pressure, you tend to get a large change in the actual size of the band. So we think about that as being elastic. But if we simply have another piece of cloth that was made out of different kind of product that woven differently, such that it wasn't thought of as being very elastic, then a similar change in physical pressure would bring about a much smaller change in the size of the fabric. Maybe it wouldn't bring about any change at all. That would be thought of as being inelastic. So elastic is where we have a large change in one variable in response to a smaller change in the other. Inelastic is where we have a small change in one variable in response to a larger change in the other. And then unitary elastic is where we have a proportionally equal change in one variable in response to a change in another. So if you gave something just a little bit of physical pressure and you also got just a little bit of change so that the changes were proportionately equal, you would think of that in this case as being unitary elastic. Well, the basic elasticity equation, as we note here, is referenced by this small Greek n, or mu, which we recognize is a percent change in labor of worker I versus, or in response to, a percent change in the wage for, again, worker I. So let's think about how this might look in the goods market. First, let's think about something that is perfectly elastic. And when we're talking about the goods market, we're now not talking about the labor market. We're just talking about the market for a produced good or a service that one might buy, let's say at retail. And I want to think about something that's perfectly elastic. So a small change in price will yield a large change in the quantity of the good being demanded. So let's think about this. We'll give our basic equational or structural setup here, where we have the price axis and we have the quantity axis, Q and P. And something that's perfectly elastic would have a demand curve that's perfectly horizontal, such that at this price, we'll call it P prime, at P prime, then the demand curve, I called this labor demand, I should have just called it quantity demanded, that the demand curve is such that at that price, there is virtually an unlimited quantity that could be acquired, but at anything above P prime, literally there will be nothing demanded. So any price above P prime There's no quantity demanded. Now, the way that this graphic is laid out, that would also suggest that anything below P prime, nothing is demanded, but that may not be realistic. Let's think about a good that is probably perfectly elastic, which probably means that it's perfectly substitutable. Which means that it's probably just some kind of commodity. I like to think about Coke and Pepsi. To me, Coke and Pepsi are the exact same good. They are brown, fizzy sugar water with some caffeine added to give you a little bit of energy. They cost typically the exact same dollar amount when you buy a can or a case or whatever in the grocery store. And if one of them costs significantly more than the other, or even 5 or 10 cents a can more than the other, then you probably would say, no, I will take the lesser expensive product there. Now, you may be among one of those that thinks that Coke and Pepsi are different products, and if that's the case, well, we'll forgive you for that. But the reality is they're virtually the exact same product. Maybe an even better comparison would be two different types of bottled water. Let's say Dasani bottled water and Fiji bottled water. Honestly, most of us couldn't care less which of those two brands we chose. They are water to us. And if the price of one of them is at the market price, let's say that's P prime, and that price goes up, then we probably completely eliminate our demand for that product, and we simply start buying the other one. So that would be something perfectly substitutable, and such that we know that the demand curve is horizontal. Any price above the demanded price, the price that is set in the market, no one's going to want to have any of that product. So it's perfectly elastic. Let's compare that for a moment with perfectly inelastic. Completely different connotation. So let's think about this, a different kind of product that might be able to be consumed. And to me, the quintessential inelastic product is insulin. If one has diabetes and one needs insulin, then I'm pretty sure that we would say that there is a perfectly vertical demand curve, such that the person with insulin will demand a certain quantity, we'll call it Q prime, of insulin regardless of the price. And if they can't get that insulin, then they will pay whatever price is necessary to get some, because without insulin, if I understand the condition correctly, the consequence is death. So this is perfectly inelastic. So regardless of the change in price, there is no real change in quantity demanded. The amount that is needed is the amount that is needed at virtually any price. Well, we think about this kind of a product as being not at all substitutable, so no good substitutes. And it's probably not an easily acquired commodity either. So now let's think about this with respect to the actual labor market itself. We may see that the conditions we placed on the goods market for perfect elasticity, perfect inelasticity, may not be completely realistic, because maybe there is a little bit of elasticity for insulin. Maybe there's a little bit of inelasticity for Coca-Cola or Pepsi. So let's think about a good or a product in the labor market, a certain type of labor, and what that might mean to us in terms of something that's elastic. So again, we'll do our basic structure here. And let's say that this is a low-skilled worker. We're going to say this person is a ditch digger. Or this type of worker is a ditch digger. Now, I think that most of us probably have the intellectual and physical wherewithal to pick up a shovel and dig some kind of a ditch. Some of us maybe dig it better than others, some dig it faster than others, but I think that any individual with basic physical and intellectual capacity can dig a ditch. Well, if that's the case, and we think about this, a ditch digger probably has a relatively shallow slope to the demand curve. This would be the labor demand curve, such that if we go from a price of, let's say, W prime and Q or L prime to a not very much lower price, say W prime prime, then that's going to yield really a rather large change in the quantity demanded to L prime prime. We see that a relatively small change in wage yielded a relatively large change in labor, and that's because this is a very elastic product in the labor market. Almost anyone can dig a ditch. It's highly substitutable. It takes very low real skills to do so. Let's contrast that for a moment with maybe something that we would agree would be inelastic, and then we'll talk about them a little bit further. I would think in the labor market that a brain surgeon probably is a pretty highly skilled individual and probably is not very substitutable. I'm pretty sure that if I need a brain surgeon, then I want a brain surgeon. I don't want a ditch digger. I don't want somebody that is waiting tables. I don't want an engineer. I want a brain surgeon. Well, if that's the case, then we're looking probably at a relatively steep demand curve, labor demand curve. In fact, it might even be very steep along these lines. It's still downward sloping. This isn't perfectly vertical, just as this one wasn't perfectly horizontal. In fact, it's not even horizontal at all. But this one certainly is relatively steep, which would suggest to us that if we have a price of W prime, and that yields to us some L prime, or number of labor units, and if we have a rather large change in wage to W prime prime, well, based upon how we've structured this curve with a very inelastic demand, we have a very small change in the labor units. So a large change in wage created a very small change in labor units. And that's simply because this is not a very substitutable type of labor. But if we think about it, maybe a ditch digger and a brain surgeon aren't that dissimilar. I mean, what is a brain surgeon other than a highly skilled, extraordinarily precise ditch digger? And the ditch that's being dug is in one's head in order to get into the gray matter and take care of what might need to be taken care of. They're a highly skilled ditch digger. Well, I'm fairly confident that if I needed a ditch digger, I could either hire a ditch digger or I could hire a brain surgeon, and either of them probably could dig a regular ditch in my backyard or on my construction site. But if I need a brain surgeon and the only person available is a ditch digger, well, that ditch digger might be able to pick up a very small shovel, i.e. a scalpel, might be able to start to dig the ditch in my head, but my guess is the product or the outcome wouldn't be very successful. So this is a basic discussion of labor demand elasticity. As we continue to talk about demand elasticities, labor demand elasticities in the other segments of this module, we'll find that pretty much everything that we say with respect to labor demand elasticity will be similar to labor supply elasticity, although we won't go into any real detail about labor supply elasticity, except to say that labor demand elasticity we would expect to have a negative value if we had a way of calculating this, and you'll see in a few segments that we do have a way of calculating this, but we would expect it to have a negative value because the labor demand curve is negatively sloped. The labor supply curve, let's say we had a labor supply curve coming through this particular model, the labor supply curve, if we had one, would be positively sloped, and because of that, we would expect that a supply elasticity would have a positive value.